Hi, welcome to my channel where we provide an alternative view to the common narrative. Today is a Sunday, the 21st of May, just for your record, and I'm going to talk about the Patriot missile systems versus the Kinzhal missile attack. So if you are interested, please continue watching. Welcome back to the channel. As you probably heard, the Russians are claiming that they have fired Kinzhal ballistic missiles or air-launched missiles at a Patriot missile defense battery located in Kiev, and they claim they have destroyed this battery. Naturally, the US and Ukraine basically denies that the battery has been destroyed. And I believe both parties are half right and half wrong. And today I would like to discuss a little bit about some of the technical aspects and some of the practical aspects around these types of missile systems and claims. Firstly off, the Patriot system is not a single system. It has a radar system and has a command and control vehicle, and then it has about 3 or 4 launchers, sometimes even 8, depending on the circumstances. But as far as I understand, the Patriot system that was delivered to Ukraine and situated at the Zhuzhny airport, if that's the right name, at Kiev. They were stationed there, and there was even some video made available on the attack. Now, as far as I understand, there were 3 launcher vehicles, or if you can call it like that. Usually the Patriot system is also dispersed, so the radar system is not there where the launchers are, and neither is the command system. So if the Russians claim that they have destroyed the Patriot system, they have probably destroyed the launchers and not the complete systems. And that is why I say the US and the Russians are basically half correct. Now, the video that I saw, some private citizen probably even pinpointed the location of these Patriot missile systems, launchers. Let's call them the launchers. And he obtained some footage of this, and you can clearly see the firing of missiles from that location. And then you can also see 2 huge incoming explosions at the same location from which these missiles were fired. In total, there were about 32 Patriot missiles fired within 2 minutes. Which is type of either a panic station, or either the Ukrainians decided that's it, might as fire all the missiles because they're going to get destroyed or whatever. But they fired 32. Now, the Patriot system is not a new system. It was developed, about in 1988. Then we had the PAC-1 system, which was more anti-aircraft systems and earmarked for anti-ballistic missiles. And then we had later the development of the PAC-2 systems, which was a more advanced system than the PAC-1. And I will talk about the specifications. And then we had the PAC-3 system that was later introduced. And it's a little bit unsure which PAC system, missile system, it was delivered to Ukraine. But the PAC-2 systems has a launcher for each rocket or missile, and it can carry about 4 launchers per launch vehicle. But the PAC-3 system is a much smaller missile, or lighter missile, and actually 4 of these PAC-3 MSE type of missiles can be fitted into a single launcher of a PAC-2. And that means that actually 16 PAC-3 missiles can be mounted on a launch vehicle. Now, if you consider that 32 missiles were fired by the Ukrainian Patriot missile defense system, then it means that 2 launchers has fired, and they fired all of their 16 missiles that they had on the launchers. And that means basically that the PAC-3 system was used and delivered to Ukraine. Well, delivered to Ukraine and then used in this position at the airport. Now, just to, I'm going to give you a little bit of specifications about all these systems, and then you can make up your own memory, and I will discuss it a little bit. But let's say the PAC system was developed in 1976, and it was deployed in 1984 as a PAC-1 system. And it is, with all the envisaged upgrades, it is going to be used up till about 2040. So that's another 16 years the Americans are trying to implement, keep the system. They have also, in the process, developed new missiles with new capabilities. But at this stage, we are stuck with the PAC-3 MSE missile systems. And then we have the radar section. Now, that has been upgraded multiple times and improved and so on. But I don't want to really talk about the radar system because that's quite complicated. And also, it doesn't have any impact on the idea that it can shoot down a Kinzhal hypersonic missile from the Russians. But I thought it would be a little bit interesting to give you some information. And this is, you know, we always talk about technology, the latest technology, the latest microchips, the latest processors in weapon system, but I can tell you straightforward from my experience in the military industrial complex, it's all about reliability. Reliability, reliability, reliability. And that means you use electronics or systems that are fairly old and have proven for themselves, and where the manufacturing methods have been improved, and it becomes very reliable. And military specs are usually much higher than industrial type of specs. If you want to buy a certain, like even a transistor, it has, say, a 5% variation between the various resistors on a single value. In a military industrial complex, it's allowed to have 1% and less variation between them. But in this case, just on the electronic system of the Patriot system, the VCC is the main computer within the Patriot systems. It's a 24-bit parallel militarized computer with fixed and floating point capability. And just in comparison, you can get now a 32-bit processor on a system. It's a system on a chip basis. It's like ESP32 multiprocessors with Wi-Fi, with USB, with everything installed there, and it runs at, say, 20 megahertz. That's a standard. And then in South Africa, that item costs 180 South African Rand, which is $1. So that's normal, old technology that's already available in this year, 2023. But here we have a 24-bit parallel. That one is also parallel. A computer with fixed and floating point capabilities, arithmetic. This one also had it. And it is organized in a multiprocessor configuration that operates at a maximum clock rate of 6 megahertz. The computer control, like I said, $1. You buy a more powerful system on a chip with an ARM processor and memory and all the other stuff for $1 that runs at 30 megahertz clock speed. It is also parallel, has a lot of other features that go much more superior than this one that is used in the Patriot system. In any case, so this computer controls the operator interface that calculates the missile intercept algorithms and provides limited fault diagnostics. Compared to modern personal computers, it has somewhat limited processing power, although it has been upgraded several times during Patriot's service life. Now, just for instance, your processor in your PC is a multi-core that has maybe 4 or 8 computer chips on one chip, on one die, and it runs at 3.5 gigahertz. And it has a built-in numerical processor hardware. So compare that to the processor that is in this Patriot system, and you can understand why it is why its systems are old and why Russia doesn't need the latest technology to build missiles and radar systems, whatever. In fact, if you read a little bit more, they, I think it's Soyuz, no? Soyuz rocket system, the one that goes to the space station, goes to the space station, still runs on a XT computer chip, which comes from 1982, 84. That's it. You understand the type of computer systems that these systems, because they are reliable and all the bugs has been sorted out, the processing has improved insignificantly since 83, and you can guarantee that that electronic component won't fail. Contrary to more modern processors, which are much more complicated and more prone to defects and failures. Now this is number one. I thought was very interesting. But in any case, let's continue on. Pack 1 missile had a range of 90 kilometers and a speed in excess of about Mach 2.8. And then came the Pack 2 missiles. Now both of them were anti-aircraft missiles, and they had a proximity fuse which will explode in a vicinity of an aircraft and then destroy the aircraft by multiple shrapnel pieces that is generated during the explosion. And that is how it's supposed to destroy that aircraft. But the missile Pack 2 is about 5.8 meters long. It's not small. It weighs about 900 kilograms. It has a range of 160 kilometers. It flies at 3.6 Mach. Please remember the 3.6 Mach. It has a flight at altitude of 32, but an engagement of 24 kilometers. And it has a warhead of 84 kilograms. And then something also you must remember, that it has, in its head, it has a cone. It has a radar, small radar system. So the guidance type is tracked via missiles. The missile tracks a target. And also it has a semi-active radar. What it means is basically that the base station can illuminate the target and the missile will pick up the bouncing back or the reflection of the radar from the target. So this is the Pack 2. This is a fairly large one and fairly heavy. But it can only go about 32 kilometers and engage in ballistic missiles at 24. That's the height, the maximum height it can go. And then we have the Pack 3. And it was developed from the Strategic Defense Initiative, Iran missile. It is dedicated almost entirely to the anti-ballistic missile mission. So this thing is developed to encounter or destroy incoming ballistic missiles. Yes, it can destroy cruise missiles. Yes, it can destroy aircraft and so on. But that is more than guided by the radar system, by the control system. But the function of the Pack 3 missile is, and it is a radical change from the Pack 2, it is a hit-to-kill missile. So it doesn't destroy the aircraft or the ballistic missile via fragmentation explosion, but it's destroyed by, it has to physically hit the ballistic missile or the aircraft to destroy it. And in this maybe, I don't know why, how, but they still have a proximity fuse, but a lot less fragments, about, I think about 20 fragments, which is not really effective. So maybe it's just there to somebody decided to put it on there. So I don't really understand why they have this proximity. And the question then arises, why have they changed the principle from a fragmentation proximity fuse to the hit and kill? Because this again makes it very difficult, near impossible for the Patriot system to hit a Kinzhal missile. Since the Kinzhal flying is supposed to fly so much faster. But people claim, hey, the Patriot system can destroy it. No, the success rate of the Patriot systems in the first Gulf War was very bad, very poor. It has missed a lot of targets, hasn't destroyed much, but that report apparently is supposed to be under wraps. Nobody should know it, but I've seen a copy of that, or a similar. And in the second Gulf War, there was the problem again. There was supposed to shoot down Scud missiles. But the problem is that the Scud missiles were modified by Saddam Hussein, and that made them unstable, and that basically made them more difficult to hit. So the Patriot system didn't work that well as either. And then if you follow the Yemen war, there were multiple times where the Houthis fired missiles and UAVs at their oil infrastructure and cities, and basically they went through and the Patriot system couldn't shoot down these units. And Saudi Arabia property was damaged. I mean, this is like, you can Google it up. And they had the Patriot system. We all thought by ourselves, why the hell didn't they shoot it down? They had all these expensive military systems. So, in my opinion, the whole Patriot systems accuracy is still in doubt in any case. But let's just get back to the PAC-3 missile. It is a lot, well, it's 5.2 meters long, so a little bit shorter, but it only weighs 373 kilograms compared to the 900 kilograms of the PAC-2. And that's why you can fit basically 4 missiles in the canister of a PAC-2. And it has a distance, well, smaller, 60 kilometers. It does fly at 4.1 Mach, 4.1, and then it has flight altitude of 36 kilometers. And it has a warhead, which I don't understand, of 8.2 kilograms. So I'm not sure why it was like the hit to kill and then still have this warhead. And the guidance type is active radar homing, and it also has an active radar seeker. Now that means in the cone itself, it tries to find the target, and then it locks into target, like a air-to-air missile, you know, like infrared and radar and stuff like that. It tries to lock on the dingers. But it is a little bit maneuverable because it has in its head, it has about 180 small solid propellant, or tiny, that would be a better name, tiny solid propellant rocket motors. So when it has to adjust a little bit, it fires one of those rocket motors and then it recorrects. So it's fine-tuning to attack a ballistic missile that has a predetermined trajectory. You can understand. So if the missile is off course by wind or whatever, it can adjust a little bit to focus on the specific warhead. Now, also shooting ballistic missiles and ICBMs is very difficult to counter in any case, because they sometimes release multiple ammunition, multiple warheads with decoys and stuff like that. And if you select the wrong physical warhead but a decoy, then you have to make an adjustment, and that is basically why the motor is inside the PAC-3. But it's insufficient to maneuver a missile against an aircraft who makes a lot of maneuvers. And if you want to, then aircraft just has to make multiple maneuvers until the tiny rocket motors are exhausted, and thereby the missile can't steer itself anymore. You know, have you ever seen a launch of an Iskander missile? You can see it goes up and then it goes into that direction. So it goes from this and that, and then it goes. I'm talking about that type of motors. Now, we also know that the Kinzhal missile can maneuver in the final stages. So that's another benefit apart from its speed. So if it makes a couple of dives, that Patriot tiny motors are exhausted and you can't maneuver in again, and you can forget it. That's it. And because the path of the Kinzhal missile is not predetermined, it cannot lock on and destroy it. So I'm not sure how the US can claim that this system can actually work and take down the Kinzhals. Even with the cruise missiles, I'm sure that the cruise missile's path can be reprogrammed during flight and even in terminal area, and it will exhaust the maneuverable motors of the PAC-3 system. So, yes. So these are guys also like, let me just see if I read something there. It can acquire its target itself in the terminal phase of its intercept, which improves the reaction time of the missile against a fast-moving ballistic missile target. The PAC-3 missile is accurately enough to select, target, and home in on the warhead portion of an inbound ballistic missile. The active radar gives the warhead a hit-to-kill, kinetic kill vehicle capability that completely eliminates the need for a traditional proximity fuse warhead. That is basically what is written there. Now, if you look at the shape of the Kinzhal missile, and if you look more or less at its performance and so on, there is a general assumption that the Kinzhal is just an air-launched version, slightly modified, to the Iskander ballistic missile that the Russians field. And we all know how capable it is, but I thought I can compare it to the Patriot System. Now, the terminal, it can travel at a terminal hypersonic speed of Mach 627. And it can reach an altitude of 50 kilometers and a range up to 500 kilometers. That's the range. But it also says that it never leaves the atmosphere. So what you are talking about is you are talking a vehicle that travels at 6 to 7 Mach in dense air. If you like I said, if you ever watch the launch of an Iskander missile, and there are plenty on YouTube, it has a fairly flat type of trajectory. Okay, so we are thinking on Mach 6 and 7. And just for the sakes, which I thought was very interesting, it can carry conventional warheads, including a cluster munition warhead, a fuel-air explosive enhanced blast warhead, a high explosive fragmentation warhead, an earth penetrator for bunker busting, an electromagnetic pulse device for anti-radar missions, and it can also carry nuclear warheads. Now this is a versatile system. Now it was, development started in 1988, and mass production started about in 2008. It says that the target for the missile system can be located not only by satellite and aircraft, but also by a conventional intelligence center, by an artillery observer, or from aerial photos scanned into a computer. That means the target can be entered into the missile system with various means. It can also be retargeted during the flight in the case of engaging mobile targets. So if you have fired and the target has moved, you can easily reprogram it during flight mode, which is important. And what is also a unique feature of the Iskander is the optical guided warhead, which can also be controlled by encrypted radio transmission, including such from AWACS and UIV. This is a ballistic missile that has an optical camera in its front head so that it can lock onto a target, and that can be controlled and steered by a radio link from a UIV or an AWACS system. And there's also the electric optical guidance system provides a self-homing capability. And the missile onboard computer receives images of the target, then locks onto the target with its sight and descends towards it in it says supersonic speed, but we will talk about that a little bit later. And it also says, according to rumors, in flight, the missile follows a quasi-ballistic path, performing evasive maneuvers in the terminal phase of a flight and releasing decoys in order to penetrate missile defense systems. And apparently the American observers have notified or observed some of these decoys that were launched. So it's very similar to the Kinzhal. During the terminal phase, it can maneuver. Maybe not as much as the Kinzhal, because I believe the wingspan is a little bit smaller than the Kinzhal, but it's still, like I said, a modified version of the Iskander. And its altitude can go up to also 50 kilometers. It has a length of 7.3 meters, which is higher than the Patriot. It weighs about 4.6 tons or 4,600 kilograms. And it has a warhead of between 700 and 800 kilograms. And it travels at between Mach 6 and 7. And just for the sake, it achieves a circular area probability, that's a hit radius of 5 to 7 meters. And the destruction force of this warhead is claimed by the Russians from a single warhead of about 25,000 square meters, which is about 2 football fields. So this thing is a monster. Now, firstly, you have now a little bit of background between the two types of missile systems. Now think about this. Number one, the Iskander can travel to a height of 50 kilometers, but the Patriot system can only engage it at 24 kilometers height. So in this period where a missile comes down, the Iskander or the Kinzhal, it can decide and maneuver away from the Patriot system. Or it can decide, right, he's going to do evasive maneuvers and so on. And that already defeats the Patriot system. Then, and this is, okay, then it has an optical view, so it can adjust it. It has radio linkage, which it can adjust it. It has its own terminal evasive maneuvers it can do. It can receive retargeting during flight. There's nothing that the computer can do about this missile. Nothing. But the most contentious issue is about the speed of this missile. Now, I've looked around several pages, a lot of pages, and from my own engineering experience and so on, flying at Mach numbers is not the same. The math just doesn't work. It's not as simple. You know, the Navier-Stokes equations work below Mach 1, where we have nice aerial air properties and frictions and stuff like that. But everything changes after the Mach 1. Certain terms that you could have ignored under Mach 1, you can't ignore any minute higher. But it's not that simple either. So the field at that stage is still not really determined. Now, I've read one article, brilliant article. It's a huge analysis about speed and about the capability of Kinzhal. And if you read it, it sounds impressive, really, it sounds impressive. The guy is supposed to know what he's talking about. He shows the videos, he shows other videos. It's impressive. But unfortunately, it's not everything is true. It's only half of the truth, and it's actually missed the ball. Because in the state, it's all about, and we all heard it about, is the hypersonic speed of a missile. And then we have the buildup of friction of air, and the heat that is a problem, etc., etc., etc. And this can cause huge problems. And that's why the impact speed of the Kinzhal missile cannot be hypersonic. That is wrong. Firstly, I would talk about the misconception about re-entry of space vehicles. The re-entry of space vehicles enter the atmosphere at a speed of between Mach 23 and Mach 40. And as it enters the atmosphere, yes, it heats up. And as it heats up, it has a plate of material that counters the heat built up and so on and so on and so on. And then also the statements mark that during that period, there cannot be any radio communication. So there cannot be any update of any GLONASS satellite systems. There cannot be any update or communications and so on because there's a plasma forming around the vehicle. And that is also true, to a certain sense. One has to look at the flow of air around any entry vehicle. It is on the front. We have seen airflows over cars and so on. We can see it just goes like that and it tries to attach to the vehicle. But at the back, there's a sort of a lower pressure. And, it's like a wedge going through air and the air flows like that. So that means basically that the rear is open. And if you have the satellite, in today's modern times, if the satellite and the rear of the entry vessel is aligned, they can receive radio signals, or they're supposed to be, because that part has no plasma. It has no huge flame areas, but there will be distortions, there will be noise, a lot of noise, so I'm not totally sure. Theoretically, it can be done. Practically, I'm not so sure about that. But then it slows down. And I've tried to find out what is the maximum speed that any missile or object can travel in, okay, I wouldn't say a height of 10 kilometers or 2 or 3 kilometers. Yes, our maximum city there, Joburg, our thing is about 2,000 meters above sea level. And say the Kinzhal wants to destroy that on the ground, then that's 2,000 meters above sea level. I'm not sure what Kiev is, but it should be. The army, if you design a missile, you have to design a missile for those conditions. Just like you have to design a missile for minus 40 degrees, minus 50 degrees, not because it gets that cold, but if it's airborne, the temperature there is minus 50 degrees. And it has an impact on solid motors and explosives and all other stuff that goes with it. But it complicates the design. So firstly, there is no plasma bubble around an Iskander or Kinzhal missile. Nobody has seen it, and that happens at entry levels of Mach 23 to Mach 40. And hypersonic speed numbers are anything about Mach 5. Now, the Iskander travels at Mach 6 to 7, and the Kinzhal is reported to go at Mach 10. And one can understand that because it flies at huge height, and it's carried by an aircraft, and it is launched from the air in much less dense areas. So it can achieve a much higher speed at the end of the day. But it's a Mach 6 to 7, and it's not leaving the atmosphere. And it has optical. So this means already Iskander is in the hypersonic speed limit of field. So it's a hypersonic missile. That's it. That's a fact now. And because it has to receive radio updates during travel, it has optical imaging at the front. There cannot be that much heat build up. Otherwise it doesn't work. So you can assume already that a Mach 6 to 7 is fairly... All the Russian missiles are supposed to be able to handle it from a heating point of view. Also the heat point of view of, there can be other mechanical systems by putting heat. I don't know whether they go into the finer details. But you can have a huge shield before the camera. When it slows down, you can remove the shield, it becomes optical. And then in terminal phase, We are going to make all excuses like that as much as we want, but a Mach 6 to 7 is not that illogical to assume. But the maximum speed of a Patriot is 4.1. So, and it's a hit to kill. So it has to hit the Iskander, it has to hit the Kinzhal, which is traveling at enormous speeds, maybe even double the speed. And in this other story usually goes about, yes, you have a missile is launched, goes out of the atmosphere, goes to its target, re-enters the atmosphere, and then boof, ballistic missile, it goes down on its target. And the reason is that is because there's always air frictions, and that sort of lowers the distance. So if you have to fly through thick air, you're going to be able maximum range of, say, 200 kilometers, but if you exit the atmosphere, low air density, you can fly 500 kilometers. Yes, you can argue like that. But the Iskander doesn't fly like that. He never leaves the atmosphere. And he flies 500 kilometers. And the reason why is that because at the end of the day, it's conservation of energy. I know my friend is going to name me about this. But for practical purposes, in engineering, we always talk about conservation of energy. And that's how we resolve certain equations. If physics wants to talk about conservation of energy, that's a totally different ballgame, but from an engineering point of view. So what you have here is, you have a motor, chemical motor, that has so much energy that it outputs. And we assume, let's assume an efficiency of 100%, just to make it easy. So you have a lot of energy that is exported through the motor, and then it goes. And for that, it will convert chemical energy, it will convert 100% into kinetic energy, which will 100% convert it into potential energy, meaning the final height that a missile achieves. And during its flight, there will be air friction and resistance and stuff like that. So theoretically, the maximum potential height that it can reach is the chemical energy minus the friction and heat energy that is basically wasted during the flight of the. So this one will have less energy than what it's supposed to have with if there were no friction, if it was vacuums and so on. You understand that? And now it has this potential energy, and it has to come down. And therefore, again, it goes down, and then it has drag on the missile, and that one has to be subtracted from the potential energy. So this one is already less than the chemical energy. So once it hits the target, it has even less energy for what it was actually the launch was. So if you think about this, then you can say, all right, the chemical capability of the Iskander can make it so Iskander can fly Mach 10. But unfortunately, due to air friction, it has a loss of energy, and it can only fly to a Mach 7. And now it comes down, and there's another friction, and due to friction, the energy will again be reduced, and then it might only fly till Mach 4 or 5 or whatever. This is how you can argue what the terminal speed would be. But the problem is that is when it is maximum. That means Iskander is fired maximum height straight up, and then it turns and it goes a distance. But let's not go a distance. So let's assume this one goes straight up, and the chemical energy is translated to potential energy, maximum height. And when it comes down, that is maximum energy coming down and hitting the ground. At the end of the day, that's simple math. But if you fly forward and you fly, say, 20 kilometers, then you have air friction for 20 kilometers, which is also subtracted from the potential energy, which makes it less. It brings down the speed. And then if you fall terminal, you will have a different lower S-terminal final speed. But if you fly even further, like your 500 kilometers, you will have lost more potential energy, and therefore your final energy in order to attain terminal speed, hitting the ground, is even less. So it's also a question of the distance that the missile has to travel, what its final descent speed is. It's a distance. The further it flies, then more it loses in air friction, potential energy, and the less its final speed will be. So if the Iskander is fired, say 100 kilometers from Kiev, it could have struck those Patriot batteries with a speed of, say, Mach 6, but if it was 400 kilometers away, it will probably have hit those Patriot batteries with a Mach 4. Now the same thing applies to the Kinzhal. The only thing, the difference between the Iskander and a Kinzhal is that it already achieves potential energy because it's dropped by an aircraft. So it doesn't use its chemical fuel to attain potential energy. It uses chemicals to attain speed, pure speed, in a low density air environment. And that's why it can travel so much faster. And again, if it flies 500 kilometers, it will have a certain retained energy and it will hit the ground at a certain velocity. If it travels 1,000 kilometers, it will lose more energy and it will hit the ground at less speed. Now, this is more or less based on a simplified model of, or simplified view of the whole scenario. But the principle still applies. And therefore, it is so difficult to really tell you what the term, I know that I call it the terminal speed, but some people will define the terminal speed at the end of the burnout of the motor. So as you can see, it's not as simple as that. But the Kinzhal has a huge advantage over the Iskander. And that is already attained potential energy. And its chemical energy is purely transferred to kinetic energy. And there is no build-up of huge heat. Because the Kinzhal probably also has the optical systems. And can also be upgraded during flight. And has maneuverable in the terminal phase of the missile. And it has radio links during flight. There is no plasma bubble. Because it's also dependent on the friction coefficient, and that is the drag coefficient, and the drag coefficient is also dependent on the shape. But the shape on about Mach 1 is not the same requirements as the shape of a nose cone below Mach 1. The whole drag coefficient is totally different calculated because the airflow over the boundaries and the airflow and the shock waves totally change during, that's why you have this loud bang when you break the sound barrier. If I remember still, there was once saw a movie about Jaeger, the guy, the test pilot in America, who broke the speed limit or broke the maximum height or whatever. And as far as I remember, during those tests, he commented in one of the scenes that he says that when he broke the speed barrier, the rudders function turned reversed. So before Mach 1, putting back the stick will lift you up and pull forward will get you down. But after Mach 1 is that pull you back, it goes down, and pulling up, pushing forward will push you up, something like that. If that's true, I'm not sure. a pilot might actually be able to comment that. But conditions before Mach 1 and after Mach 1 are two totally different. But after Mach 1, it more or less stays the same. So considering all these facts, there is no heat problem on the nose of the Iskander. They are not traveling, well, Iskander might travel below Mach 6 or Mach 5, maybe supersonic, because it has a lot more energy to waste and it's flying through the atmosphere. The Kinzhal doesn't do it. It flies through thin air, 4 times as high as a normal airliner flies. And it converts all this chemical energy into kinetic energy. And it doesn't fly. It doesn't need to fly 2,000 kilometers. Depends on where the release. Maybe it's only 300-400 kilometers. So it still has a lot of reserve in terms of kinetic energy. And it might, and I'm fairly confident it will hit its target at a hypersonic speed. And given the limitation of the Patriot system, doesn't matter how perfect the radar system is, doesn't matter what. The limitation of the Patriot missile is its limited maneuverability. It's the fact that it can't chase down an aircraft, or it's more focused on ballistic missile with a known trajectory. It's a lot more difficult to shoot that missile down. And I'm sure that even if you take cruise missiles and you allow it to do some variations in its movement, it's going to defeat the Patriot as well. But there is one. Before I leave this topic and get to the final stage, is that the Ukrainians are claiming they have shot down 6 Kinzhal missiles. And then the Russian Ministry of Defense said, but we didn't fire so many missiles. We only effectively fired 2. He said it differently. He said actually 3 times less than what you said, which case the 2 and so on. And that's the 2 you can see on the video. So, and even if you look at the photograph that's been displayed of the debris, the part of the missile that was recovered, the nose cone doesn't even look like an Iskander or a Kinzhal. So the Ukrainians are confusing what they have shot down and what they haven't shot down. All right, but that's my story now about the Patriot. I don't believe the Patriot can ever shoot down the Kinzhal unless there are huge modifications being done. And you have a sustained motor burn, like an air-to-air missile and stuff like that. Or you have enough build-up momentum in the missile that it can maneuver and so on. The point here is as well, what's important, and I believe this is what everybody forgets and doesn't recognize. The Patriot system was given to Ukraine in limited numbers. It is capable of shooting down certain stuff, but not what the Russians are really producing. UIVs, cruise missile, they can easily be shot down by the NASAM systems and Gerard, 20mm, 30mm cannons and so on. That is what they are suited for. But the Americans has given them in order to test their systems against the new missiles of Russia. And this whole war has a huge benefit for both parties, the Americans and the Russians, of adjusting their equipment to counter the equipment of their opponents. The Americans have now seen that the Patriot cannot do it. They will try to adjust their missile, or they will go back to which is a much larger missile and has a proximity kill method and not hit to kill, which is nearly impossible with the Iskander. And maybe they make a lot of other modifications, or they fire 3 or 4 missiles at a given time in order to saturate the air that wherever the Kinzhal wants to move, there's a missile in its way, or something like that. But both parties are now testing their weapons against each other. And both parties are learning at an incredible rate. And both parties will modify their weapon system to counter the other party's missile system. And one should never ever forget this, because this is a huge part for the Americans. Anyway, guys, that's my story for today. Until next time. Cheers.